Hello everyone, thanks for tuning into the epic 8th Winter 2023-24 update from GavsWeatherVids. So here we go again, time to bring you more winter data. We are up to update number 8. We're getting close towards the business end of our winter updates. We've got 13 penciled in before the winter forecast. So yes, we're over halfway now. We're getting towards the business end of the winter updates. We're going to be looking at things like sea surface temperature, anomalies, so activity, Eurasian, snow cover, and we're going to have a lot on the stratosphere for this one as well. So sit back, relax, enjoy, and I shall talk you through our 8th Winter 2023-24 update in a moment. Just to say that first video today was our 6 AM UK weather forecast. We'll be live at 6 PM, so I'm sure I have questions about this epic 8th Winter update. Hold fire on those. I'll do my best to answer them on the live stream tonight at 6 PM. We will also begin at 10 to 14 there and combining that with plenty of long range as well. So, going to be very, very epic. Live stream at 6 PM. Thank you so to Richard. Thank you so to the amazing Richard Trott for our amazing winter updates gift. I love it, love it, love it. Thank you so much, Rich. You're going to see the swingometer from the King of Swing, Rich, in a moment as well. So thank you so to Richard. Thank you so to Shryan as well. Shryan Bruin for all of the help on this update. Shryan and Richard, hashtag Team Gav, have been working away so hard on this winter update. And it is a team effort, you know, as always, at GavsWeatherVids. So thank you so much, hashtag Team Gav, bringing you these winter updates week by week by week. Unique content. You can't find this data, these videos anywhere else online on the internet, on YouTube, etc, 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 that we are doing here at GavsWeatherVids, and it's all made possible by Richard and Shryan and Terry as well, hashtag Team Gav. It's unbelievable. Thank you so much to Shryan and to Richard. And we're naming the deer as well. So if you've got a good name for the foal, then please post it in the comments. And we're going to put all the suggested names on to the name picker. And we will be, naming the deer to go with the foal. So we're going to name the foal. So we're going to be naming the deer in a future live stream. Thank you, thank you, thank you so much. Right, with all that said, I reckon we're going to begin your 8th Winter 2023-24 update. And the first thing we can look at is the swingometer. So after 7 updates, up to the end of last week's 7th update, should say, this is how things are looking in 6, in 5, in 4, in 3, in 2, in 1. There we go. So we are now favouring a milder than average winter by 59%. To 41%. That is actually a slight swing from mild to cold. Last week's 7th winter update did in fact produce a 2% swing from mild to cold. Still very much strongly favouring a milder than average winter, of course, because of all of the previous updates, but up to the end of the 7th winter update, we favour a mild winter by 59% to 41%, and that is a 2% swing from the week before, from mild to cold. So a very slight swing there from mild to cold. Thank you so much to our King of Swing, Richard. Thank you so to Richard Trott for the swingometer. And at the beginning of next week's 9th update, you will find out how this week's 8th update has affected the swingo. So that will be the first thing you'll see at the beginning of next week's 9th update. Right, okay, exciting, isn't it? Going to start this 8th update with QBO. So quasi-Siberian oscillation is in its easterly phase, and just to confirm that with this chart from NASA, so these are the levels of the atmosphere from the stratosphere at 10 HPA, top of the atmosphere, to 30 to 50 HPA, just here, back the boundary level of the atmosphere that we call the troposphere. Now this blue-green area just here descending from the stratosphere into a troposphere, that is the easterly phase of quasi-biennial oscillation now into the troposphere. And so, as we've confirmed over previous updates, the winter of 2023-24 will be an easterly QBO winter. Let's have a look at some index data. So starting with the Arctic Oscillation observed and forecast. So the black line shows where we've been with the AA. The red lines at the end where the GFS ensembles are forecasting the Arctic Oscillation to go. Remember, these indexes, the AO, the NEO, and the same with QBO, really just reflecting the atmospheric state, not driving anything in their own term, but just tell us what the atmosphere is doing. So when we're in a positive phase of the Arctic Oscillation, we've got low pressure over the Arctic and the North Pole, and this time of year about tend to keep cold air bottled in over the pole. Conversely, when we are in a negative AO, then we've got high pressure blocking over the Arctic and over the North Pole. Now, through the middle part of that will force cold air out of the pole into mid latitudes at this time of year and into winter. So back around the middle of October, a couple of days ago, a few days ago, we was negative with the AO. It quickly went back into positive territory. Where we are right now is actually weekly positive. GFS ensembles are forecasting that the Arctic Oscillation is going to be staying in a neutral to weekly positive phase through to the beginning of November. The NEO is very similar. Again, the black line shows where we've been with the North Atlantic Oscillation. Red lines at the end showing where the GFS ensembles are forecasting the NEO to go. Quite interesting. The NEO has been in a prolonged, get your teeth in, Gab. The NEO has been in a prolonged negative phase since around the middle of September, actually. So before that, we had a week or two of positivity, but back into summer, the NEO was also in a negative phase through most of July and August anyway. Just went positive through the first half of September, then went back to negative again. Though for the past month or so, the NEO has been in quite a strongly negative phase, actually, hovering around that -1 line that we've seen just there. But GFS ensembles are forecasting the NEO will start to recover back towards neutral through the last week of October and might go weekly positive into the beginning of November. But this will be quite a strongly negative NEO winter, I think. And so that is going to be the basis of our analogues for this week's 8th winter update. So we're going to be looking at winters that are following October's with a negative NEO from around -1 to -7 on the scale here. Right, so let's do that then. Shrine got all these years together for us. So Shrine, first winter is going to, first October is 1955. The first winter is 1955, 1956. This winter is a cold winter late, so it has blocking in the North Atlantic around Greenland. It has trough of below, average heights, low pressure across northern and western Europe, and that brings the wind in from an east-northeast direction. It's mild to start in December 1955, gets very cold at the end of January, leading to a freezing cold sub-zero CT February in 1956. So next winter is going to be 1960, 1961. This one is a mild and wet winter with low pressure in from off the Atlantic, so that's an unsettled mild and wet winter. We've got 1973, 1974, again following October, with a negative NEO between -1 and -7. This one also is a mild and wet winter, actually very mild winter for 73, 74, but with lots of low pressure dominating off the Atlantic. We've got 1980, 1981. This one has some colder intervals, low pressure way to the north and the east, high pressure out into the Atlantic, winds coming in from a northwesterly direction. I think that has a cold January in 1980, or it might be February. Then we've got 1981, 1982. This is a genuinely cold winter as well, and it does follow an October with a negative NEO from -1 to -7. So this one with below average heights in from off the Atlantic, blocking around Greenland. Very much a front-loaded wind, has a really cold December. Freezing cold December. Lots of heavy snow in that December as well. It moderates a little bit around the new year, and then the cold comes back actually through the second week of January with a tremendous freeze up and blizzard. When that ends though, then the winter turns milder. It does actually have a very mild February in 1982. Next up, we've got 1988, 1989. This is a dry and very mild winter with high pressure to the south, low pressure away to the northwest, and winter coming in from the southwest. So that's a very dry, very dry and mild winter. And then we've got 92, 93. This one again with high pressure over country. Low pressure is away to the northwest up here, so that's another dry and mild winter. Does have a very cold, frosty spell around Christmas to New Year of 92-93, but otherwise it's the mild 1990s winter. We've got 97-98, so this is an exceptionally mild winter with high pressure across much of Europe, low pressure out in the Atlantic. We draw up winds from that southerly direction. Has an exceptionally mild February. February is more like May in 1998. We've got 2003, 2004 showing up next with high pressure in the Atlantic, low pressure across northern West Europe, winds again coming in from that northerly direction. So a few cold snaps coming in going for 2003, 2004, but also lots of very mild weather too. And it has, the coldest spread is actually sort of second half of February to early March in 2004, but it's not a cold winter overall, really. Got 2004, 2005, again, has high pressure out in the Atlantic, low pressure to our south and also to the northwest, winds coming in from a northwesterly direction. Again, a bit on and off. Coldest weather for this winter is, again, actually from the middle of February to the middle of March, around a 4-week window of cold weather right at the end of the winter. Otherwise, generally quite mild before that, but does have a white Christmas in northern and western regions in 2004. 0910 shows up next. This follows in October with a negative NAO of -1 to -7. So 2009, 2010 is a genuinely cold winter, the first that we've seen since 81, 82, and actually probably a colder winter overall than that, to be honest. Has blocking around Greenland. It has low pressure sent southwards along with the jet stream as well. That gets pushed a long way southwards, winds in from the east. The coldest period during that winter is from the middle of December to the middle of January, actually 4-week window from mid-December to mid-January, where it is freezing cold and regularly very, very snowy as well. But before and indeed after that, we do have plenty of cold and wintry weather in the winter of 0910. It's the coldest winter for England and Wales since 1979, and the coldest winter for Scotland since 1963, since my daddy. Wow, wow, wow. We've got 2013, 2014. This is the polar opposite, with deep low pressure in the Atlantic, high pressure away to our east, and so this is just a very mild, wet and windy winter, very stormy 2013, 2014, and then 2014-15 shows up next with low pressure to the north, high pressure out to the west, winds in from the Atlantic, a few cold snaps coming and going, average sort of temperature, but not a particularly cold winter. And then the last winter is 2019-2020. I think this one is the polar vortex of doom winter, of course, with all of this low pressure up north around Greenland and into the polar regions, and to the south we've got strong ridge over much of Europe that draws the wind in from the southwest, so very stormy, exceptionally mild. It's the PV of doom. Cold lovers, look away now if you don't want to see that one showing up. Right, let's put them back together then. This is how all Decembers combined are coming out following October with a negative NAO between -1 and -7. And it's a mild and wet signal for the Decembers, really. Low pressure dominating across much of Europe. High pressure out in the Atlantic, so there could be a little bit of cold snap potential there. But generally, I think just a mild, wet and windy signal for the Decembers. All Januaries combined keep the Atlantic thing going. Low pressure to the north, high pressure around Spain. That's always a bad sign. The cold is winds in from off the Atlantic, so a mild signal there as well for the Januaries. Bear in mind there will be exceptions to this. We know that we've got, for example, 2010 in the mix, but averaging it all out, putting all the years together, that's how the Januaries are coming out. And then all Februaries combined, which possibly has the greatest cold snap potential, but it's not great. We do send the low pressure southwards by the look of it, but we still have quite a bit of low pressure around Greenland as well. Higher pressure begins to get going over northern Europe as well, so it could just about imply sort of an easterly type influence. But overall, I think, you know, a mild winter is being favoured here with most of these years, with a few exceptions, and that's what we see when we put all the winters together. So this is how all winters combined are looking following October, with a negative LEO of -1 to -7, and it is a mild, wet, windy signal for these winters overall, with lots of low pressure to the north, bringing in the jet stream from off the Atlantic too. So yes, very much favouring a mild winter after those negative NAO Octobers. Right, well, that's the analogues done for this week. We'll have a little break there. You can digest what you just witnessed, maybe. And in a moment, we're going to have a look at solar data, actually, as we resume the 8th winter update. So I shall see you in a moment for that. But for now, let's have a little break, and I'll see you in 2 seconds. Okay, we're ready to resume the epic 8th winter 2023-24 update from GavsWeatherVids. So wow, been an epic update so far. I hope you enjoyed what you've already seen, and we're now going to resume the 8th winter update. Thank you so much, Richard, for our amazing winter updates. We've got so much to show you on this 8th update, so I better crack on a bit. Going to start off with solar activity. So this is how the solar disk is looking on our side of this day from Soham.net. Got 4 sunspot regions they are reporting at Soham. Despite that, though, solar activity is at low levels, and it's expected to remain at low levels. This is the GavsWeatherVids 8th winter 2023-24 update solar tracker sent through by Shryan. Thank you so much to the Ace Master Shryan for updating our solar tracker. The orange line and orange spots depicting each individual day's worth of sunspot and solar activity. You can see us having quite a significant drop in activity at the moment. So, of course, back around the middle part of the summer, we had this big spike up in activity, and then we had a bit of a drop after that as we come towards the end of the summer, beginning of the autumn, followed by another lift up in activity later on in September. Well, now with the orange line, orange spots, we're actually down here. We are at our lowest level of sunspot activity since back in the spring of 2023, interestingly, and that has been enough to lower the red line here, which of course is our 7-day average. That moves around quite a bit, so we don't necessarily take that too seriously. But you can see that the green line, which is the 30-day average, that is also beginning to drop down. The blue line, which is the 90-day average, that moves around much less, and that isn't really dropping all that much at the moment. It has dropped from where it was back in the middle part of the summer when we had that big ramp up in activity. But yes, it is quite interesting that it does also be solar cycle is easing off the gas a little bit at the moment in terms of sunspot numbers and activity. I'm sure it will pick up again over the next few weeks and months, but at the moment it's sort of lifted off the gas, and we're having a slight lull in solar cycle number 25. This has been sent through from Richard, so this is showing spotless days and the current spotless rate. So for 2023 so far we're at 0 days for sunspots. That means every day this year has had sunspots, therefore 0% of the year has been spotless. It's comparable to 2022, which had 1 day without sunspots, which is less than 1% of the year. Our comparable year, of course, is 2012. That's had, from solar cycle 24, and that also had 0 days without sunspots. So in 2012, every day had sunspots. The same was true the following year for 2013. So next year, in 2024, we can again expect every day of that year to have sunspots, and probably beyond that, 2025 and 2026 as well. 2027 will probably be our first year when we start noticing spotless days reappearing. That will be as we start moving down into the into solar minimum for solar cycle 23-24. Solar minimum, true solar minimum, will occur around 2030. Thank you so much to Richard and to Shryan for all of the solar data. Of course, we will be keeping a close eye on solar activity through the remainder of our winter updates. Of course we will. Right, ocean data next. So we've got our 4 areas of interest. This is how the ocean looking we did last week's 7th update. 4 areas of interest enter the region up here, Northern Pacific up here, particular focus on the Northeastern Pacific, got the Indian Ocean through there, and we've got the North Atlantic Ocean over here. Right, so that's how things looking. We did last week's 7th update. This is how things looking for the 8th update. Here we go. Now, in terms of the ENSO region, we can see not much change. All regions are displaying an El Nino signature there. All regions above average with a sea surface temperature. And as we go back to last week, and forwards to this week, we've possibly seen a strengthening of the El Nino signature through this central region. So things are warming up through the central region. They're still very warm over in the east, but possibly right towards the Peruvian coast, they've cooled a little bit. But basically, all regions of the ENSO region are displaying a pretty decent, pretty strong El Nino signature. Certainly a moderate to strong El Nino signature. In the Northern Pacific, again, let's go back to last week, that situation last week, forwards to this week. Now, we are seeing a shrinking of the cold PDO signature. I've still got some slightly cooler than average waters through here. It's still a little bit cooler through here as well. But overall, that negative cold PDO signature, I think, has weakened a bit from last week. And then in the Indian Ocean, the positive IOD signature continues, so it remains, what am I doing? It remains cool through there towards Indonesia, and it remains warmer over towards India and Asia and whatnot. And as we've explained, that is the signature of the positive phase of the Indian Ocean dipole. In the North Atlantic, again, that is how things are looking in the North Atlantic last week. This is how things look this week. So just looking very warm again, really most areas, particularly through the tropical and subtropical Atlantic and up towards Spain and whatnot. Quite warm through here as well, but it's a little bit cooler through here. Is that a signature of a tripole? Not really. You've got to cool things down a lot more really through this area to be able to say that you've got a tripole signature. This is a 7-day change, so we can see that most areas of the ENSO region, most areas of the extra-Pacific are warming. Most areas to the north of it have warmed as well. In the Northern Pacific, this area just here is cooling. So that could penetrate into like the northeastern Pacific, then that would, be very useful for getting the negative PDO signature back again. In the North Atlantic, we can see that this area has cooled a little bit, but because the sea surface temperature and odds were so far above average, despite, cooling by a degree or so over the past week in the Atlantic, actually it remains significantly warmer than normal. This area has cooled a little bit too. This area has warmed. It's warmed a little bit to south of Greenland as well. And over in the Indian Ocean, most areas are warming, actually, through much of the Indian Ocean over the past 7 days. So in terms of the sea surface temperature anomaly, this is looking in the ENSO region, region 3.4, which is the central part of the ENSO region. Basically, each blue spot depicting each individual day's worth of anomaly, and you can see that it's ticking up a little bit now from where it was earlier in October, around 1 degree above average. It is getting closer to be around 1.5 degrees above average now. Interesting tweet I saw the other day from World Climate Service. Please check out World Climate Service on Twitter. So they were tweeting about the Modoki El Nino. This is their tweet just here saying, as expected, El Nino is slowly losing its Eastern Pacific focus with the core warm anomaly shifting westwards. We've explained that a moment ago, looking at sea surface temperature. And of course, latest forecast suggests a winter Modoki index similar to 2015-16, sort of 0.4 above average. That's fair. That's a fairly typical value. Diver strongly east-based, such as 97, 98. Normadoki, like 2009-10. So this is the table. Of course, they've got the table just there, but they've had a look at. This is the table here for the long-range models. So this is looking at all the long-range models, ECM, DF, UK, MET, CFS, GEM, etc., etc., etc. And this is the, these are month periods just here, November, December, January, February, March, and these are the monthly departures for those models. So you can see, yes, we are probably going to have a Madoki El Nino, but it's expected to be a very, very weak Madoki El Nino on most of this model output. UK Met is a little bit stronger with it, so by January goes to plus 0.62, and Metro France also a little bit strong as well for December and January, plus 0.62, plus 0.60. The ensemble mean, averaging out all of these models, is plus 0.30 for the Madoki El Nino in December. That rises to 0.32 in December, 0.40 in January, and then starts to ease back again in February and March. So yes, that is technically a Madoki El Nino, but it is at a very, very weak end of the scale. Weaker, for example, than the Madoki El Nino that we had in 2009, 2010. So whilst we are probably going to have a Madoki El Nino, technically, it will be warmer in the central portion of the equatorial Pacific Ocean. Again, let's go back here and explain this. So it will probably be warmer in this region by January compared to this region. So that will technically be a Madoki El Nino. However, it's not going to be that much warmer. And so if we do get Madoki El Nino, it's likely to be relatively weak, and that means its impact, particularly for us in Europe, could have impacts for America, of course, but for us in Europe, its impacts are likely to be relatively reduced. Please check out World Climate Service. They do amazing tweets and have lots and lots of information. That's very, very interesting. Check out their Twitter. Southern Oscillation Index is getting more negative again, actually. So remember, the SOI is reflecting the atmospheric state, really. It's measuring air pressure between Tahiti and Darwin, as we see in these two columns here. Then we get a daily contribution just here. So the SOI, when it's negative, the atmospheric state will be reflective of El Nino. When the SOI is positive, the atmospheric state will be reflective of La Nina. You can see over the past 2 or 3 days, actually, the SOI got more negative. So on the 18th of October, the SOI is minus 13.09. On the 19th of October, the SOI was minus 15.09. On the 20th of October, the SOI was minus 22.56. On the 21st of October, the SOI was minus 23.47. These are very, very negative numbers. Tells us that the atmospheric state is strongly reflective of El Nino at the moment. So the atmosphere and the oceans are coupled, and therefore El Nino will continue to develop. 2023 Atlantic hurricane season is related to sea surface temperature anomalies, of course. So this is the 2023 hurricane season page from Wikipedia. These are the scores on the doors, Miss Ford. So far, we have had 20 tropical depressions. We have had 20 tropical storms. We've had 7 hurricanes. We've had 3 major Category 3 or above hurricanes. All of those numbers are up 1 on last week. I think the depressions, the storms, and the hurricanes are up 1. No change, though, for the major hurricanes. That remains at number 3. And this is our ACE page. So ACE Master Shryan has been keeping this updated for us. Accumulated cyclone energy is basically just a way of measuring how much energy all of these tropical storms are giving out individually and also on a season-by-season basis. The classification is below normal, near normal, above average, hyperactive for the season. And we go all the way back to 1850s with this, but we want to come down to the most recent year, to 2023. So ACE is now sitting for the 2023 Atlantic hurricane season at plus 133.60. That is after 20 tropical storms, 7 hurricanes, and 3 major Category 3 or above hurricanes. That is above normal. Not much change from last week, but it is an above normal season. Where we're above where we was in the totality of last season, by the way, which was 95.10, and we are above the running average up to the 21st of October, which you would expect to be at 110.10. I think we're probably going to stay above average. I think the season is starting to wind down now, though we have got Hurricane Tammy currently, but it doesn't look like that's going to get much stronger than a Category 1. If we get one more big hurricane, if we get one more, one more major hurricane, Category 3 or above, that was to last a week or two, then that will probably lift us up into hyperactive. But I've got a feeling the season is winding down, so I reckon this is going to be an above normal season rather than a hyperactive season. But we've still got a way to go. The season won't officially be over till we get to December. It's not unheard of that we can get, a big hurricane in November. So we can't say yet, but definitely we're finishing above normal for this season. But that's the most likely outcome, I think. Thanks to the Ace Master Schreier for updating that. Right, stratospheric data next. Good bits, isn't it? Good. Hope you're enjoying it. If you are enjoying this 8th winter 2023-24 update, please you like, share, subscribe. Thank you so much for doing that. This is unique content. You cannot see this anywhere else on the internet. You know, what we're doing at GavsWeatherVids over these past several years is pushing the boundaries, pushing the envelope, and it's incredible. So thank you so much, everybody. Tell your friends and family about the work that we're doing at GavsWeatherVids and try and get them to subscribe as well. Right, stratospheric data. So this our temperatures are currently looking at 10 APA over the North Pole set against average. The black line is the current season. The grey line is the trend, is the average line. And you can see we're basically very close to average with the temperature at 10 HPA at the moment. We're somewhere around minus 65. That's about where you expect us to be with the temperature in the stratosphere over the North Pole at 10 HPA at this point in October. If we go a little bit lower down to 30 HPA, again, you can see the black line is very, very close to the grey line. It has dropped a little bit from where it was about a week ago, but it's still very close to normal. Though at both levels of the stratosphere, 10 and 30 HPA, temperatures are about where you'd expect them to be, somewhere around minus 65, at both levels, really. So if we have a look at the forecast data from the latest GFS run, again, the blue colours here, these are the cold temperatures at 10 HPA in the stratosphere over the North Pole. You can see around minus 64, something like that, very close to average, as we've already explained. So as we run through, we're possibly going to see a little bit of a cooling taking place, but not overly so. Over the next week or so, we keep the temperature somewhere around the mid-minus 6s, really, over North Pole. Maybe edging down slightly to minus 67, minus 68, something like that. But, it won't be a particularly big deviation. And that's over next week. Beyond that, heading into the extended range with the GFS run. Again, keeping those temperatures somewhere in the mid to low minus 6s over the North Pole. Nothing particularly dramatic going on. No dramatic cooling, no dramatic warming either. Temperature remain quite static. So if we come back here, you can see that on the scale, you expect things to be cooling down. So by the end of October into the beginning of November, you expect to be around minus 70 with a temperature at 10 HPA. That's roughly where the GFS is there. Minus 68, something like that. So we'll be very, very close. We'll be saying with that black line, very, very close, I think, to the grey line, to the long-term average. Of course, what we're looking for is going to be a sudden stratospheric warming. So when you get a major warming of the stratosphere, and this is when we get into the winter, really, about occasionally you can get sudden stratospheric warmings in November but typically they occur, through winter and get more likely as the winter goes on. So when you get a sudden stratospheric warming, SSW, you dramatically warm the temperature at 10 HPA and also at 30 HPA in the stratosphere. This has an effect of disrupting the polar vortex as that warm air propagates down from the stratosphere into the troposphere. That has the effect then of disrupting and weakening the PV. So these cold colours, these blue colours, are basically the PV at their roots in the stratosphere, if you see what I mean, the polar vortex at its roots. This is from 2013, New Year's Day 2013. You see the dramatic red colour here over Siberia. That is a dramatic warming of the stratosphere taking place over Siberia. Look what happens by the 5th of January. Those deep red colours very dramatically start pushing from Siberia into the North Pole itself, starting to displace these blue and purple colours, which again is the polar vortex at its roots. Now by the 10th of January, well, let's go to the 8th of January, you see how those blue colours very much being pushed out from the pole into towards Canada, North Atlantic, Northern Europe. Notice how this sudden stratospheric warming from Siberia has propagated into the pole, and this in 2013 did actually lead to the complete obliteration of the polar vortex. We see a dramatic split there of the PB by the 11th of January. Notice the two lobes of blue go off onto either side of the magnitudes, and in between we've got these green and yellow colours. That is a classic split of the PV. That is the result of that dramatic, very dramatic sudden stratospheric warming that occurs just after the new year of 2013. And of course that eventually led to a cold winter. It leads to increasingly cold winter weather in January, February, and then a freezing cold and very, very snowy March in 2013. But not every sudden stratospheric warming does that, but that's at the more dramatic end of the range. So this is from the ECMWF. These are the weekly temperature forecasts for 10 HPA, temperature anomaly forecast, I should say, for 10 HPA. Starting with week 1, we're going to go for the next 6 weeks worth of data. We're starting with week 1, which is the 23rd to the 30th of October. So a bit of a warming this week. It's actually next week will be taking place over Siberia compared to average, certainly not a sudden stratospheric one, but a modest warming there. That is week 2, which is the 30th of October, 6th of November. Got a little bit of a warming happening in the North Atlantic there. Again, it's all around the edges of the North Pole. Over the North Pole itself, it is quite cold toward the Canadian side, but otherwise close to average. This is week 3, 6th to the 13th of November. Again, nothing overly dramatic going on. Maybe a bit of a cooling towards the eastern Siberian side of the North Pole by then. The pole itself very close to average with the anomaly there. That's week 4. Again, nothing particularly dramatic showing up. Week 5 is the 27th of November. A little bit of a warming then starting to appear over Siberia. That's not an SSW. And then week 6 though looks quite dramatic. This is the 27th of November to the 4th of December. A large warming is taking place there, all the way from Northern Europe, right way around to the Pacific side of the Arctic. The focus looks like it's over Siberia. So that is a significant warming of the stratosphere that will be taking place there in 6 weeks as we move, in the 6th week, I should say, as we move to the start of December. We cannot say that is a sudden stratospheric warming, put a scale on, given that these are only anomalies to average. It does have that kind of look of the SSW though, given its large extent and scope from Northern Europe all the way over towards the Pacific. But, these charts not able to say that that is an SSW, but it will certainly be a significant warming of the stratosphere anyway that's going on there at the end of November into the start of December. That's 6 weeks away, so it's a very, very long way off. Another way of looking at the polar vortex is through the zone of wind. So the zone of wind is basically telling us how strong the polar vortex is. When the zonal wind is stronger than average, and the PV will be stronger than average. When the zonal wind in the stratosphere at 10 hp is weaker than average, then the PV is basically weaker than average. If you get sun stratospheric warming, you'll tend to get a reversal of zonal winds. That's this 0 line just here. So any of these ensemble members, looking at the E7WS season model now, anything's ensemble members that are going for a reversal of zonal winds that are down here, they're seeing an SSW most likely. So this is the forecast from the E7WS seasonal model over the next few months. We've got dates in month periods on the side: November, December, January, February, March, and April. And then we've got the strength of zonal wind on the side here. So we can see that the black line, which is climatology, which is average, is just here. So the zonal wind looks like it's going to be weaker than average through November and into December. We see that with the blue-red line. Possibly though, the zonal wind goes a little bit stronger as we get through from December to January. But it looks like it's weakening off again later on in the winter from January through to February. But I think because last month the E7WF was kind of hinting at a significantly weaker than average zonal wind, therefore polar vortex, I think the E7WF model has kind of backed away back a little bit in the past month. This is Meteo France. Now this is seeing a more solidly weaker than average zonal wind. So again, we've got the black line here, which is the average over the next few months. The blue and red lines are quite substantially under the long-term average, again telling us that Meteo France season model is seeing that the zonal wind, the polar vortex, therefore, is likely to be weaker than normal throughout much of this season, actually starting off close to average at the moment, but certainly weakening off as we go through November and into December, January, and February. Quite a few of the ensemble members from Meteo France are going for a reversal of zonal winds as well, especially from January through to February. This is DWD. This is seeing an even weaker zonal wind, actually. This is the DWD German model. Again, the black line is the average for this point of the year and beyond it. So starting off actually a little bit stronger than average with the zonal wind in October, but through November to December, we see the blue and the red lines weakening quite substantially. Again, this tells us that DWD is forecasting a pretty significant weakening of zonal winds, and actually there are several ensemble members that are going for a reversal of zonal winds in November to December, which is very unusual. That's very, very unusual to see that. Then it kind of picks the zonal wind up a little bit from December into January, but still you'll notice the red and blue lines are significantly under the black line, so still much weaker than average. And then through February, weakening the red and the blue lines off again. And throughout the winter, though, the main point, I think, throughout the winter, the means are underneath the average throughout the winter, and quite substantially so in large portions of it. But particularly early on, that's very unusual, as I say, to see the zonal winds so far underneath average in November to the beginning of December. So could we get some very, very early warming event of the stratosphere? DWD kind of hinting that. The JMA is much closer to average with the zonal winds. So again, black line is average. You'll notice the blue and red line maybe slightly under normal, but nowhere near as much so as we saw there with DWD in particular, but also Meteo France. So JMA much closer to average with its forecast for this winter in terms of the strength of the zonal wind, maybe even going a little bit stronger than average through December to January just there. Not much sign with the JMA, at least until later on in winter anyway, of any particularly dramatic developments in terms of the stratosphere late on, possibly hinting at some sort of warming event maybe in February, but I think the JMA much less bullish on that. And then we've got UK Met, which also looks quite interesting for the earlier part of the winter anyway. So again, at the moment, starting off a little bit stronger than average with the zonal wind, but the UK Met is also seeing quite a significant weakening of solar winds taking place through November into the beginning of December. Later on, January to February strengthens the solar winds, so strengthening the polar vortex through the second half of winter. But early on in the winter, going for a relatively weak solar wind, there are a few ensemble mean members within the UK Met that are going for reversal solar winds. Not that many of them, so probably not seeing a technical SSW, but just a weaker than average polar vortex and or solar wind through the early part of the winter before strengthening of the PV takes place through the middle and second half of the winter, potentially. We'll keep you updated, of course we will, on stratospheric developments as we get closer to the winter 2023-24, and as ever, what's going on with Strat, always a big, important, pivotal part of our countdown to winter and during the winter itself as well. Right, gonna have a little break there, and when we return, we're going to look at Eurasian snow cover. That's the fan favourite. We'll see what's going on in terms of Eurasian snow cover to end this 8th winter update. But let's have a little break, and I'll see you in 2 seconds. Okay, we're back and we're ready to resume the 8th winter 2023-24 update from GavsWeatherVids. It's been epic so far. I hope you've enjoyed what you've seen. If you have, can you please like, share, subscribe, tell your friends and family about the work and the content that we're doing at GavsWeatherVids. You cannot see this unique content anywhere else online, so please tell everybody about what we're doing at GavsWeatherVids with these incredible epic winter updates. Right, here we go then. This is our Eurasian snow cover was looking where we did last week's 7th winter update. So that's how the scenario was across Siberia and also Scandinavia. Let's have a look at the latest. This is it. So seeing a significant increase in snow cover across eastern portions of Siberia, an increase in snow cover across northwestern parts of Russia as well, and an increase in snow cover across Scandinavia. So compared to last week, snow cover has increased in Russia and also in Scandinavia too, which of course you expect given that we are going further on into October. Right, let's get rid of that. Let's start seeing how we're comparing though to past years. So this is how we compare for Scandinavian and Russian snow cover to last year, to 2022. So we have more snow cover this year compared to last year across Russia and also across Scandinavia. That is 2021. So I think we're very close to 2021 for Russian snow cover, but we are lagging behind for Scandinavian snow cover, interestingly. That is 2020. We're behind 2020 for both Russian and also Scandinavian snow cover at this point. That is 2019. We're also behind 2019, very substantially so, for Russian snow cover and also a little bit for Scandinavian snow cover. That is 2018. So we're ahead of 2018 for Scandinavian snow cover, well ahead of 2018 for Scandinavian snow cover, probably a bit behind for Russian snow cover. That is 2017. What do you make of that? Well, we're ahead of 2017 for Scandinavian snow cover, and probably a little bit behind for Russian snow cover, although there won't be much in it. The areas covered are slightly different. 2016, so what do you make of that one? We are ahead of 2016 for Scandinavian snow cover, but behind it for Russian snow cover. That's 2015. We're ahead of 2015 for Scandinavian snow cover, but behind it for Russian snow cover. That's 2014. So we are behind 2014 for both Russian and also Scandinavian snow cover, well behind it. By the way, we look at this because, again, early build-up of snow cover, it increases the chance or increases the strength of the Siberian high. Now, I've noticed in the comments people are noting that the years that have like the biggest build-up of snow cover are not necessarily followed by cold winters. All we're looking at with this is the strength of the Siberian high. But remember, Siberian high can go two ways. Siberian high can go that way, and if it does that, then it will bring the cold air into Europe. That can sometimes get to us over in the UK and Ireland. The Siberian high can also go another way, though. The Siberian high can also go that way and move over the pole and down into Canada. When it does that, it will take the cold air out of like Siberia and out of the Arctic and push it down into Canada and North America. And that can actually blow up the jet stream and result in like mild, wet, windy weather for the UK and Northern Europe. That's exactly what happened in 2014. you know, in 2013 and in 2014 in that winter, and some degree 2014-15 as well. But just keep in mind, but you know, although if you get an early bit of a snow cover, it might well equate back to an increase in the strength of Siberian high, but an increase in the strength of Siberian high does not necessarily guarantee that we're going to get any particularly cold weather out of it in Western Europe. Anyway, back to 2014, so we're behind 2014 for both Scandinavian and also Russian snow cover. That's 2013. What do you make of that one? So again, we're behind 2013 for Russian snow cover, perhaps a bit ahead of it though for Scandinavian snow cover. That is 2012. What do you make of that one? So for 2012, I think we are probably ahead of 2012 for Russian snow cover, but the areas covered a little bit different. Maybe a little bit behind it actually, and Scandinavian snow cover, I suspect we're a little bit ahead. That is 2011. That's quite close to the current scenario a Russian snow cover, I think, but we are ahead of it for Scandinavian snow cover. That is 2010. What do you make of that one? Again, probably quite close for Russian snow cover. Ahead, though, for Scandinavian snow cover. That's 2009. What do you make of that one? Again, I think that is pretty close to this year as well. That might be the closest, actually, in terms of this part of Russia just here, anyway. Let me know in the comments what you think. This is all subjective, so let me know in the comments which years you think we're closer to. I think 2009 is a pretty good match, actually, for 2023. Perhaps the best we've seen so far. That's 2008. So I think we're behind 2008 for Russian snow cover, but ahead for Scandinavian snow cover at 2007. So, again, that's quite close to 2007 for Russian snow cover, but ahead for Scandinavian snow cover at 2006. We're well ahead of 2006 for Scandinavian snow cover, but behind for Russian snow cover at 2005. Again, I think we are a little bit ahead of 2005 for Russian snow cover, and well ahead for Scandinavian snow cover. Basically, we're close. We're close to a lot of years. You know, behind some, ahead of some. We're somewhere in the middle of the pack, I think, for Russian snow cover, but I think doing quite well for Scandinavian snow cover. That's 2004. Again, same idea, ahead for Scandinavian snow cover, but behind this time for Russian snow cover. That's 2003. So with that one, I think we're ahead of 2003 for Russian and Scandinavian snow cover. That's 2002. We're behind 2002 for Russian and Scandinavian snow cover. That's 2001. We're ahead of 2001 for Scandinavian snow cover, but behind it for Russian snow cover. That's 2000. Ahead of 2000 for Scandinavian snow cover. Probably behind it for Russian snow cover. That's 1999. Ahead of that one as well for Scandinavian snow cover, and for Russian snow cover, probably quite close to it. That's 1998. So for 1998, again, ahead for Scandinavian snow cover, I think, this year, but probably behind for Russian snow cover. So we're somewhere in the pack, for Russian snow cover, but doing quite well for Scandinavian snow cover. Finally, we'll just go back to 1966 at Rutger Snow Lab. So we won't do a comparison now. Let's get rid of that, but feast your eyes and remember how that looked. So, starting with 1997. So, I think for 1997, we're ahead for Scandinavian snow cover, behind for Russian snow cover. 1996, we're ahead of 96 for Scandinavian snow cover, probably quite close for Russian snow cover. 1995, we're behind 1995 for both Russian and Scandinavian snow cover at this point in October. We're ahead of 1994, though, for Scandinavian snow cover, and probably ahead for Russian snow cover. We're behind 1993 for Russian snow cover, but ahead for Scandinavian snow cover, and the same is true for 1992 as well, I think. We're ahead of 1991 for both Russian and Scandinavian snow cover, I think. We're behind 1990 for Russian snow cover, but ahead for Scandinavian snow cover. We're behind 1989 for Russian snow cover, but ahead for Scandinavian snow cover. We're ahead of 1998 for both Russian and Scandinavian snow cover, and the same is true for 1987 too. We're probably a little bit we're behind 1986 for Russian snow cover, ahead for Scandinavian snow cover, and the same is true for 1995. Actually, we're behind 1995 for Russian snow cover, but ahead for Scandinavian snow cover. 1984, we're behind for Russian snow cover, but ahead for Scandinavian snow cover. 1983 is same is true. Really, I think we're behind 83 for Russian snow cover, ahead for Scandinavian snow cover. We're behind 1982 for Russian snow cover, but ahead for Scandinavian snow cover. We're behind 1981 for Russian snow cover, but well ahead for Scandinavian snow cover. We're ahead of 1980 for Scandinavian snow cover, probably quite close or a little bit ahead of 1980 for Russian snow cover. 1979, we're ahead of that one for Scandinavian snow cover, probably quite close for Russian snow cover. We're behind 1978 for both Russian and Scandinavian snow cover up to this point in October. We're behind 1987 as well for Russian and Scandinavian snow cover too. We are well behind 1986. Well, listen, 1986 at this point in October, we had already got a snow line to the west of Russia, and most of Scandinavia was covered as well. Remarkable after that hot summer that we had in 76. However, we are ahead of 1975 for Russian and Scandinavian snow cover, and for 1974 we're behind that for Scandinavian snow cover, but and also behind for Russian snow cover as well, actually, I think. 1973, I think we are close to that. That might be one of the years that we're closest to for Russian snow cover, maybe Scandinavian snow cover as well. We're behind 1972 for Scandinavian snow cover and Russian snow cover. We're also behind 1971. For 1970, we're behind that for Russian snow cover, probably ahead of it for Scandinavian snow cover, no date of 69. We're behind 1968 for Russian and Scandinavian snow cover. And for 1967, we're ahead of that for Scandinavian snow cover, but we're probably behind for Russian snow cover and closely matched. And lastly, 1966, I should say, we are behind that for both Russian and also Scandinavian snow cover. Wow. Epic. What do you make of that, everybody? That was a rattle through, wasn't it? That was a definite rattle through. Did all of that in 10 minutes. Goodness gracious me. I don't know. So there we go, everybody. That is your 8th Winter 2023-24 update. It's the plot is thickening. Please let me know in the comments what you think, which years will be closest to there. Eurasian snow cover, waiting to happen, the Stratospheric, etc. You know, this has been up there with the very best winter updates, I think. So I hope you've enjoyed it. You have, please smash that like button. Okay, thank you, Shona, Richard, and Shryan, hashtag Team Gav, for all of the help on this epic 8th winter update. We're going to be live at 6 p.m. So if you've got any questions about this winter update, then please fire away. And I will do my best to answer your questions on the live stream tonight. We will also have long range and a 10 to 14 day included in that live stream too. At the beginning of next week's 9th winter update, you'll see how this 8th update has affected the swingometer. So that'll be the first thing up at the beginning of the 9th winter update. Don't forget, next weekend as well, next Saturday, we've got the second Winter 23-24 seasonal model roundup as well. Okay, well, how long's it been? At 57 minutes. The longest so far, I think. Goodness gracious, they're getting longer, aren't they? As we have more data to process. At 57 minutes, that's all for now. Thank you so much for watching. And we'll see you again next week with the next installment. But for this one, that's all for now. Thanks for watching. Bye for now.